me. I always expect the best. Yeah. Our objective for today, I can factor polynomials completely. I can factor polynomials completely. So now notice that I wrote polynomials instead of quadratic trinomials. We've been working with quadratic trinomials, but quadratic trinomials are polynomials, right? Yes. So therefore, instead of addressing polynomials, you can say quadratic trinomials. But we're going to factor completely. That means we're going to use all the strategies that we learned for this chapter, okay? Including the ones that we just learned yesterday in regards to difference of squares and perfect square trinomials. Remember that? So now check this out. We know what quadratic trinomials are. We know our steps. However, look at the steps. There's something a little bit different of these steps to the steps that I gave you before. Look at it. Talk it over with your neighbor. What do you see is any time that you wanted to remember a step will be the first two steps. These are the two steps that you need to know straight off for factoring completely. You need to know that you need to factor out GCF and you need to check for patterns. Okay? So now, GCF, from this point forward and for the next chapters to come, you need to make GCF your BFF. So, you see what I did right there? Okay. So from now on, anytime that you talk about quadratics or polynomials, first thing is GCF. Agree with me? And if they ask for factors and you factor out GCF, guess what? At the end, you need to add the GCF to those factors. So with that said, copy this down, please. Example number 1, and it says, write the black text. It says, tell whether each expression is completely factored, if not factored. Copy that, please. Example 1. Everybody copied it already? Yeah. All right, it says, tell whether each expression is completely factored, if not factored. So check this out. What is the first thing you need to check for? GCF. So, is there a GCF here? Yes, it's 5. Open a big parentheses. 5 divided by 5 is 1. 1 times x cubed, x cubed. Negative 10 divided by 5, that's negative 2x squared. Negative 15 divided by 5, that's negative 3. So that was step 1. What is step 2? Check for patterns. Can we check to see if this is a perfect square trinomial? Let's see. Can we find the square root of this one? No, because it's got a cube. This needs to be an even number one, right? Okay. So since it's not, and we cannot this is not a perfect square trinomial, we can't use the two parentheses in the Power Rangers, right? Therefore, we're done. This one, at this point, is completely factored. Okay, example 2. Example 2, that was example 1. We already finished. Example 2, 7x cubed plus 28x squared plus 21x. We're going to do this one together. Once again, what is step 1? Okay, so what is my GCF? 7x is correct. Open parentheses. We're left with, let's see, 7 divided by 7 is 1. X to the second. Plus 28 divided by 7, that's 4x. Plus 21x divided by 7x is 3. So now, if we look up, let's check to see if there's a pattern that maybe we do our shortcut and we don't have to do all that work. Square root of this? Yes. Square root of that? No. So there's no shortcut for this one. So let's do the long way. Here we go. We open two parentheses. What's the next step? Back to the first term. Yep, x and x. Then Power Rangers. What goes underneath? 4, and that's our sum. And then at the end is 3, our product. What factors of 3 add up to 4? 1 and 3. So my factors are x plus 1, x plus 3. But don't forget about the friend. BFF, there it is. Now it's completely factored. Example 3. Yep. Copy this. It says, and we're still, guys, we're still checking to see if it's factored completely. If not, we factor. So example 3A is 3x squared times 6x minus 4. And for 3B is parentheses x squared plus 1, close parentheses, over parentheses, x minus 5. Copy that. Let's do this one together. Now be careful with these. Everybody look up. Some of you saw that it's already like this. You're like, oh, this is a GCF. Right? I mean, by the looks of it, isn't this already factored out? Yes. So by the looks of it, it could be. However, check it again. Is there a GCF for these two? Yes. What is that? 2. So then we're left with 3x minus 2, right? 6x divided by 2 is 3x. Negative 4 divided by 2 is negative 2. However, there was already a GCF before that there, or a factor. You bring that down, and you multiply them. What is 3x squared times 2? 6x squared times 3x minus 2, and now it's completely factored. Copy that, please. Now, check this out. Last night, there was something about checking patterns. So, could we have checked to see if this was a difference of squares? Yeah, we could have checked because it has a subtraction, right? Is everybody following? Yeah. So the only thing is that I didn't check that because this one does not have an exponent here. Therefore, if I was to do this, square root of 6x, we can't. That's why we can't do that. However, look at this one. This kind of looks like a difference of squares, but what's missing? The subtraction, so that therefore this is not difference of squares. However, is there a GCF other than 1? No. Look at this one. This one could be difference of squares, but what is it missing? The little exponent, right? So therefore, is there a GCF for this one? No. Since there is none for this one, there is none for this one. Therefore, this one's already completely factored. Okay, go to the next one, example 4. See if you can do those two by yourself, example 4A and 4B. 4A says 5x squared times x minus 1, close parentheses, and B says 4x plus 4 times x plus 1. See if you can do those two. Go. Okay, let's see. Look at this one. It looks like it has a GCF already, but I'm going to check again. Is there a GCF in here? No, other than 1, no. However, could this be a difference of squares? It has a difference, but does this have an exponent? No. So since there's no other GCF and there is no pattern here, therefore this one is already completely factored. Okay, let's look at this one. First of all, does anybody see a GCF in this one? Yes. What is that? 4. Very good. And we're left with x plus 1. Does this one have a GCF? No. I bring that down. And let's see. No difference of squares? No. And is there another way I can write this? How about 4 times x plus 1 squared? That is correct. And that's completely factored. Copy that if you didn't have it. All right, let's go to example 5. Copy this down. Example 5. Example 5 says, factor factor 10x squared plus 48x plus 32 completely and check your answer. So on this one, notice the instructions are a little bit different, so I want you to write it completely, please. This one, they're saying that it can be factored. Notice, factored that completely, right? Yeah. And check your answer. Let's see what it said on the previous one. On the previous one, it didn't say factor it completely. It says, tell whether if the expression is already completely factored. They're not telling. On this one, they didn't tell you whether it was or whether it wasn't. On this one, they're telling you that it's not because they're asking you to do it, right? And then we're going to check. So let's do that. So copy that. Example 5, factor 10x squared plus 48x plus 32 completely, and then check your answer. So let me get rid of these words right here, and we're going to use this piece. So let's go over our process. Step 1, we're going to check for what? GCF. So what is our GCF for all three terms? 2. Open a big parenthesis, and we're left with 5x squared plus 24x plus 16. Okay, so that's step 1. Step 2, check for patterns. Let's see. Can we find the square root of this one? No, because of the 5, we're going to get a decimal, right? So therefore, on this one, we have to do the long process. We need to open 2 parentheses. There it is, 2 parentheses, Power Rangers. Our middle term is what? 24, that goes here. Now, before you give me an answer, think about it. What goes here? 80. We need to multiply the first times the last. And when do we do that? Whenever there's a leading coefficient here and then that it wasn't a GCF. Okay? Yeah.
You could, okay, you know how you're supposed to, like, divide by the and they're all, like, even, can you still divide by 2? Or
if there, can you divide by 2 again?
No, not in this person, but, like, in another situation, can you still divide even more?
No, if you already took out the GCF, you shouldn't be able to. Okay, so with that said, factors of 80. 1 times 80, 2 times 40, 3 times nothing, 4 times 20. What else? 5 and 60. Oh, but we already found it, right?
Yes.
4 and 20, but I can write it as 20 and 4. So now check this out. If we look up, now I bring this down. 5x squared. Now, pens down really quick. Let me show you something. The reason, before I used to tell you this, the order doesn't matter, is because it didn't matter. However, to make it easier to factor, pay attention to this. What is the multiple of 5? Is it 4 or is it 20? That's why I wrote it there, so I can write it right here. What comes after? 4x. What is a multiple of 4? 16. You see what I did right there? So like that, when I group them, it's easier to factor. What is GCF for these two? 5x. Thank you. We're left with x plus 4. What's GCF of these two? 4. And we're left with x plus 4. So now what's GCF for these two? X plus 4. And what's left? 5x plus 4. And are we done? No, don't forget about the DFF. The 2, you need to bring it down. Make sure when you're factoring completely or just factoring, you point to this and you write factors. Because if not, some of you are all over the place and you don't understand what you're writing. Okay? Any questions? Okay? Let's go to the next one. Example 6. Copy this down. Example 6. It says, factor 8x to the 6, y to the second, minus 18x to the second y to the second. Example 6. Completely and check your answer. So they're saying that it's not factored. They're asking you to factor it. I'm going to give you a head start for this one and see if you can do that by yourself. Go through the steps and see what you get. Go. Okay, let's see. Step 1. Everyone, GCF. What number divides this that divides that? 2. However, what else can we find here and here? X squared and y squared. So that's our GCF. So let's see. What is 8 divided by 2? 4. X to the 6 divided by x squared, that's x to the 4th. Y squared divided by y squared is 1, so that's gone. Minus 18 divided by 2 is 9, and x squared to y squared, they're already here, or that divided by that is 1. So, step 1, GCF. Are we there so far? Step 2, check for patterns. What does this look like? Difference of squares. It's a binomial. It has a subtraction. Let's see if the pattern works. Square root of the first. 2x squared. Square root of the second. 3. Is it a subtraction? Yes. So my factors are 2x squared minus 3 and 2x squared plus 3. And don't forget about the BFF. 2x squared, y squared, and now it's factored completely. How are we doing? Okay, number 7. Copy this next one down, please. Example 7. It says, factor each polynomial completely, same instructions, and check your answer. Example 7. So then they give us 4x cubed plus 16x squared plus 16x. See if you can do this one by yourself. You should be able to do this one within 40 seconds. Go. So, step 1, GCF. What is GCF, everyone? 4x. And we're left with x squared plus 4x plus 4. Are we there so far? Step 2, check for patterns. Let's see. I'm going to check to see if this one, since it's a trinomial, and see if it's a perfect square trinomial. Can I take the square root of the first?
Yes.
Yes. Square root of the last?
Yes.
Yes, so far so good. Let's see. If that multiplied and times 2 gives me the middle term, then it is a perfect square trinomial. Let's see. X times 2, that's 2x. 2x times 2, does that give me this?
Yes.
Yes, so it is a perfect square trinomial. So therefore, my factors are, check this out, x plus 2 squared, and don't forget the BFF, 4x, and we're done. Piece of cake. Yeah, if you put 2, that's not the greatest common factor. That's a factor that's common for all of them, but that's not the greatest.
If you put like 2, then would it be more work? Or
Yes, it would.
Still get the same?
I guess so, yes. Now check this out. For those of you that skipped this step about checking patterns, you probably still got the same answer, but you did the long way. Check this out. What would be the next step if you didn't check a pattern? You open 2 parentheses, right? Factor the first term, x, x. Power Rangers, we got 4. Got 4. What factors of 4 add up to 4? 2 and 2. That's how we get x plus 2. X plus 2. And what's another way of writing this? Like that. And don't forget about this here. Example number 8. Copy this down, please. It says, factor each polynomial completely. Check your answer. 2x squared y minus 2y cubed. Copy that one, and we're going to do this one together. Example 8, they're telling us factor each polynomial. That means that it can be factored. Okay? Now, on the other one, we didn't check, but we'll check this one just to make sure that we got the same answer. Let's see. So, step 1, GCF. What is my GCF? First of all, 2. What is another thing that each term has?
Y.
A y. So, therefore, my GCF is 2y. So, therefore, what is 2 divided by 2? 1. And we're left with x squared, and we already, y divided by y is 1, okay? Minus, okay? 2 divided by 2 is 1, so, okay, we're good. Y cubed divided by y, that's y squared. So step 1 is done. GCF is done. Step 2, what did we say? Check for patterns. It looks like a binomial. It looks like it could be a difference of squares, right? So let's see. Square root of the first, what do we get? X. Square root of the last? Y. Is it a difference? Yes. So my factors are x minus y, x plus y, and you bring down the BFF. Bam. And let's check this just to make sure that we got it right. Get your area model. We're going to check. This is x minus y, x plus y. Let's see. What is x times x? X squared. What is x times y? xy. What is, let's see, negative y times x? Negative xy. What is negative y times y? Negative y squared. We're multiplying. Can we combine like terms? Yes. Negative xy and xy, what does that give us? 0. They cancel, so what do we have left? X squared minus y squared, and don't forget about that, the BFF, 2y. We multiply that in here. What is 2y times x squared? 2x squared y. What is 2y times negative y squared? Negative 2y cubed. Piece of cake. And the last one, here we go. Copy this one. Factor each polynomial completely. Oh, not that one, sorry. That one. Yx squared plus 3x minus 2. Okay, step 1. Michael. GCF. Do we have a GCF? No. So for this one, step 2, check for patterns. Let's see. Square root of this? Yes. How about this one? No. So it's not a perfect square trinomial. So therefore, we have to do all the work. Here we go. Open parentheses. Straight to Power Ranger. Our middle term is 3. That's our sum. And what goes up here? Negative 18, because we multiply the first times the last. So 1 times 18, 2 times 9, 3 times 6. Which one of those adds up to or subtracts to this? 3 and 6. And this one tells me the big one is positive, so this one is negative. So bring down the first term, 9x squared. Then it's minus 3x. I got it from here. Then plus 6x. Then at the end, minus 2. Bless you. Let's group. What's our GCF for these two? 3x. We're left with 3x minus 1. What's our GCF for these two? 2. And we're left with 3x minus 1. What's our GCF for these two? 3x minus 1, which is this one and this one. What's left? 3x plus 2, which is here and here. Was there a GCF? No. So therefore, these are my factors. Homework for tonight is on page what? Page what?
525.
Numbers 1 through
41.
Okay, so you're going to turn in your homework on your way out. That's for homework tonight. Have a good one. Enjoy your homework. See you guys tomorrow.